75 million years ago, Earth was not a quiet or gentle world. It was a planet of extremes, shaped by powerful forces operating far beyond human timescales. Dinosaurs dominated the land, massive reptiles adapted to climates warmer than today, and ecosystems rich with life. Rivers flowed wide and slow across ancient floodplains, feeding forests thick with ferns, cycads, and towering conifers. These rivers were lifelines, supporting herds of herbivores and the predators that followed them. The climate was generally warm, with no permanent polar ice caps, and seasons were mild compared to the world humans know. Nothing about this planet suggested sudden freezing, especially not in seconds. And yet evidence locked in stone tells a different story, of a moment when a living river stopped instantly, as if time itself had been cut. The river flowed through what is now northern Asia, winding across a lush prehistoric landscape. Its waters carried sediment, fallen leaves, fish, and microorganisms, all moving steadily downstream. Along its banks, dinosaurs drank and hunted, leaving footprints in soft mud. Everything about this environment spoke of continuity and motion. Rivers carve landscapes slowly, changing over thousands or millions of years. They do not stop. They do not freeze solid without warning. But preserved within rock layers from this period are astonishing geological snapshots. Fish frozen mid-swim, ripples locked in place, sediment layers undisturbed as if water had turned to stone instantly. This was not gradual cooling. This was a sudden, catastrophic halt. For decades, scientists struggled to explain how such preservation was possible. Traditional freezing, like that seen in modern permafrost, takes time. Water cools, ice forms, organisms struggle or move before death. But these fossils show no signs of struggle, no displacement, no chaos. Fish are preserved with mouths open, gills expanded, bodies align naturally with the current. Fine sediment remains perfectly layered, as if the river simply stopped flowing in a single moment. Whatever happened here acted faster than biology could respond, faster even than instinct. One hypothesis points to an event far more violent than cold weather. During the late Cretaceous, Earth was geologically active. Massive volcanic systems were erupting across the planet, releasing enormous volumes of ash, gas, and aerosols into the atmosphere. If a sudden volcanic blast injected sulfur-rich material high into the sky, it could have triggered an abrupt atmospheric shock. In certain conditions, this could cause temperatures to plummet locally in seconds rather than days. Supercooled air masses, heavier than normal, could collapse downward, flash freezing everything they touched. Such events are extremely rare today, but in a warmer, more volatile ancient atmosphere, they may have been possible. Another theory suggests the involvement of cryogenic flooding from underground sources. Beneath Earth's crust lie vast reservoirs of pressurized fluids. A sudden tectonic rupture could have released supercooled water or gas into the river system. If methane hydrates or other cryogenic compounds were destabilized, they could absorb massive amounts of heat instantly. The result would be thermal shocks so extreme that water would crystallize almost immediately. This would not resemble ice forming in winter. It would be more like matter snapping into a frozen state under overwhelming energy loss. The most unsettling possibility involves a cosmic trigger. Earth has always existed within a dynamic solar system. Asteroids, comet fragments, and cosmic debris frequently pass close to the planet. A small but extremely fast-moving object entering the atmosphere could generate a powerful shockwave without leaving a traditional impact crater. Such a shockwave could compress air, alter pressure systems, and trigger rapid cooling in localized regions. If this occurred above a river basin, the energy transfer could flash freeze water and life within seconds. No crater would remain, only the frozen moment preserved in stone. Whatever the cause, the effect was absolute. The river did not merely freeze, it ceased to exist as a flowing system. Life within it ended instantly.
Fish did not flee, sediment did not scatter, the surface did not crack or churn. Instead, everything was locked in place, preserved as a geological photograph of a living ecosystem interrupted mid-motion. For paleontologists, this kind of preservation is extraordinarily rare. It represents not just death, but timing, an event captured at the exact instant it occurred. Beyond the river itself, the surrounding environment shows signs of sudden stress. Plant material appears damaged, not decayed. Soil layers suggest abrupt exposure rather than gradual burial. Nearby animal remains show similar preservation, indicating the event was not confined to water alone. This was a regional catastrophe, not a seasonal shift. It did not unfold over days or weeks. It happened faster than dinosaurs could run and faster than fish could turn. Such an event would have had profound ecological consequences. Rivers are arteries of life. When one fails suddenly, everything connected to it suffers. Plants dependent on regular flooding would wither. Animals that relied on the water source would be forced to migrate or perish. Predators would lose hunting grounds. Even insects and microorganisms would face sudden collapse. While this event did not cause a mass extinction on the scale of the asteroid that would strike 10 million years later, it served as a reminder that Earth's systems could shift violently without warning. The late Cretaceous world was already under stress. Climate fluctuations, rising sea levels, and volcanic activity were pushing ecosystems towards instability. Events like the frozen river may have occurred more than once, scattered across the planet, creating pockets of sudden devastation. These localized disasters weakened ecosystems, making them less resilient to future shocks. When the asteroid finally struck 66 million years ago, life was already living on the edge of adaptability. What makes the frozen river so haunting is not just the science, but the implication. It shows that life on Earth has always existed at the mercy of forces far beyond survival skills or evolutionary advantage. Strength, size, and dominance mean nothing when physics itself changes in an instant. The dinosaurs drinking from that river were not failing, they were not declining, they were simply in the wrong place at the wrong moment in deep time. Modern science continues to analyze these formations using advanced imaging, isotopic analysis, and climate modeling. Each new study refines the timeline, narrowing the window of the event to mere seconds. The evidence increasingly supports the idea that this was not slow freezing, but instantaneous thermal shock, a moment so brief it left no chance for reaction, only preservation. 75 million years ago, a river flowing through a thriving dinosaur world was silenced in 3 seconds. Water became solid, motion became memory, life became fossil. The cause remains debated, but the outcome is undeniable, a frozen heartbeat of prehistoric Earth captured forever in stone. It stands as one of the most unsettling reminders that the history of life is not shaped only by slow change, but by sudden moments when the planet itself decides the outcome. The river that froze in 3 seconds did not merely stop flowing, it revealed a truth written into Earth's deep past, that beneath the appearance of stability lies a world capable of instant transformation. And in that ancient silence, preserved beneath millions of years of rock, lies a warning etched in time.